Now we are going to see what is meant by polynomials. CBSE for CBSE 9th standard. What is meant by polynomials? It is nothing but the algebraic expression which have non-negative integral exponent. Okay. For example, it can be written as, so p of x is equal to a power an raised to power x power n, a n minus 1 x power n minus 1, a n minus 2 x raised to power n minus 2 plus a n minus 3 x power rise x power n minus 3 plus etc. up to a1 x plus a0. This is the polynomial where the polynomial p of x, which is in one variable, which is written in the form of algebraic expression in terms of x. So this is written as p of x. And here an minus 1, an minus 2, an minus 3, a1, a0, and they are called as real numbers. Okay, they are called as real numbers. And here an is not equal to 0, and here a1, a2, a3, etc. up to an, they are the coefficient of xn minus 1, xn minus 2, x raised to n, x to the power of n minus 3, x, etc. So this form of and n is called as degree of the polynomial. So this is the standard form of the polynomial. So we have the polynomial in one variable with respect to y. We have polynomial in one variable with respect to x also. And we have constant polynomial. We have constant polynomial, and what is meant by constant polynomial? A constant polynomial, it is of degree 0. It is called as constant polynomial. So for example, all the real numbers, all the fractions, all the negative fractions, where there is rational, irrational numbers, they are also called as constant polynomial, and it is of degree 0. And what is meant by zero polynomial? What is zero polynomial? Zero is also known as zero polynomial, and the degree of the zero polynomial is not defined. And what is the degree of the polynomial? The highest power of the variable in the polynomial is called as the degree of the polynomial. And we have the different type of polynomial equation. That is, for example, p of x is equal to, that is, p of x is equal to 4x power 7 plus 6x cube plus 5x square plus 9. So this is the polynomial which is represented in terms of one variable x, and it has a highest power of degree 7. So this is the polynomial of degree 7. So this is the example, and what is meant by degree of the polynomial is clearly explained. Evaluate. Now we are going to see few sums in polynomial. It is very simple. Usually asked question. If f of x is equal to 3x plus 5, we have to evaluate for f of 7 and f of 5, and we have to find the value for f of 7 minus f of 5. So the given polynomial equation is f of x is equal to 3x plus 5. If x is equal to 7, we have to substitute the value of x in f of x. F of x, that is the given expression, and you have to find the value. That is, f of 7 is equal to 3 into 7 plus 5, which is 21 plus 5, which is 26. And find the value for f of 5. Substitute the value of x is equal to 5 in the given polynomial equation. So this becomes 3 into 5 plus 5. So this becomes 15 plus 5, which is equivalent to 20. Now we have to evaluate f of 7 minus f of 5. We have found the value on substituting the value of x is equal to 7 in the given polynomial equation, which is equivalent to 26. Similarly, we have substituted the value of x is equal to 5 in the polynomial equation, and we obtain the value as 20. So now you have to substitute the given value in the equation, that is f of 7 minus f of 5. Therefore this becomes 26 minus 20, which is equal to 6. It is very simple question, repeated question. So you may get such type of question in very short answer type in MCQs. It is easy to evaluate, easy to secure good marks. Now we are going to see remainder theorem for class 9 CBSE, and we have a simple basic formula for division. As we know, dividend is equal to divisor into quotient plus divisor into quotient plus remainder, and this is the basic division polynomial formula. And according to the remainder theorem, according to this, we have p of x and g of x, p of x and g of x, and p of x should be greater than or equal to g of x, and the g of x should not be equivalent to 0. And then the given polynomials, we get the quotient and the remainder as q of x and r of x. So according to the remainder theorem, this can be written as p of x when divided by g of x, it gives the quotient as q of x and the remainder as r of x. That is, when p of x is divided by g of x, we get the quotient q of x and we get the remainder r of x. This is the crux. Okay, what is the remainder theorem? This is the crux. And for example, we are going to evaluate a simple sum. Let's see now. Divide p of x by g of x. Given p of x is equal to 3x square plus x minus 1. G of x is equal to x plus 1. How will you divide this? And we are using remainder theorem. And here let us divide p of x by g of x. So x plus 1, this is the divisor. And what is the dividend here? 3x square plus x minus 1. So we have to divide this. How will you divide this? So we have 3x square here, we have x plus 1 here. So you have to make 3x square 0. For this we multiply 3x here. 3x into x, you get 3x square. 3x into 1 plus 3x. Now we have to change the sign. So minus, so minus. So this gets cancelled. X minus 3x, which is minus 2x. We have to bring the next term, which is minus 1. So we have to make minus 2x as 0. So for that, we have to consider minus 2. So minus 2 into x will give you minus 2x. Minus 2 into 1 will give you minus 2. We are changing the sign. So this will become plus, this will become plus. So cancelling the terms. So you get the value 2 minus 1. You get the value as 1. The remainder is 1. So 3x square plus x minus 1. That is, dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. So 3x square plus x minus 1 equal to x plus 1 into 3x minus 2 plus 1. So this way, after evaluating the term, that is, dividend is equal to divisor into quotient plus remainder. After when you substitute the value of divisor and quotient plus remainder, you get the value of dividend. So this is the example for the remainder theorem.